Right, good morning. My name is Jari Hemminki. I come from Palo Alto Networks, and I'll talk about Palo Alto Networks Enterprise Security Platform. And that will take you from detect and remediation strategy that we just heard about to actually preventing the attacks. And let's start first on a couple of things that have been changing and has been missed by the platform talks that we heard from other vendors. There's a lot of things changing in the IT environments, like the service production types. Now the service production goes into virtualized data centers. The networks go into data centers as well, a software-defined networking part. We're talking about private clouds. We're talking about public clouds producing services on those environments. Now, that's, of course, from the attacker's perspective, those are vectors they can use for gaining access to the information they are seeking for. Of course, the applications themselves have been changing like we've been seeing in the recent years, and attackers are not stupid. If they have a free software they can use in the attack, they will certainly do so. Just to give you an example of a very useful software that you could use in attacks, this is something called G-Bridge. I don't know if you know a G-Bridge software. But it's quite handy. I could use it myself if I was that kind of a guy. But it's a client software I can install in a machine, and I can create a peer-to-peer network, so I can have peers in my network. And that will synchronize folders from that machine over a Google Talk. So basically, it looks like a Google Talk application, and you can synchronize the folder using that software. The only thing you need is a one UDP port open from inside out, and off you go. Your folders are there. Very handy software. There's other ones like that we've been seeing in the customer environments when we do proof of concepts or tests. One of my favorite is the log me in application that you can have anytime, anywhere, any device access to a machine that has the log me in client installed. Basically what it does is the log me in client just has a SSL tunnel to a proxy on the internet, and through that proxy you get the RDP connection for that machine. And from that you can then expand your presence in the environment. So encryption, massive amount of applications, 25% all the traffic we see globally is encrypted. So what about looking at that encrypted traffic if we're talking about cyber defense? If that's a blind spot for us, that's a big blind spot, and we should be doing something about that. Especially because the applications that typically are using encryption are risky ones as well, the Dropboxes, the Gmails, etc. And how we consume those applications is changing as well. We're talking about mobility, and a lot of companies that we are seeing actually are moving business processes to be supported by the mobile devices. And it really doesn't matter which kind of industry they are in. If it's a defense, if it's a manufacturing, that's where we go. What I'm saying that once we're talking about cyber defense, we have to take all these into account when we make our defenses. And today, when we talk about enterprise security platform, we need to have the security capability in the cloud, in the virtualized data center, software-defined network, and in the mobile devices and the endpoints. The breaches are the fact of life happening every day. Every week there's a new breach. We all heard about that. Last week it was JP Morgan Chase, Target breach. We've had used in many presentations before. What's happening normally is the planning the attack phase using just the intelligence over the internet that users are happy to put their own information nowadays into. By using that, the attacker then uses an exploit to deliver a malware in a client machine, in an endpoint. After that, establishes a command and control channel for that malware and does the lateral movement and kind of concretes the access for that network so that he can have more presence in the network. Eventually steals the data and and off you go with with that data. Some of the people call this a kill chain. We do too. And most of the kill chains include endpoint. Now, this is a critical thing. What if the attacker is not traversing the network at all, like in Stuxnet, for example, the traditional USB part? Uses a zero-day exploit, a vulnerability that he exploits, malware that is never seen before, and uses a command and control infrastructure never used before. What happens then? Our current capability, I agree with Cisco's presentation that is not the greatest one. That's why I'm meaning the current defense capability of organizations today. Because it all starts with the stateful inspection firewall that is port-based, and then you add on top of these different mechanisms of detection, like application control, etc. URL defense, modules. That's what we call UTM, Universal Threat Management Appliances. They all have their own separate rule bases, and it's not integrated. Then you have a port-based anti-APT sandboxing solution for port 25, port 80, etc. It's all port-based in the beginning. And you miss the blind spot. Typically, the APT sandboxes don't work if it's encrypted traffic. What do I do then? Miss the whole 25% of my traffic. Do we think the attackers don't know how to use SSL encryption? We have to be able to look into that as well. All these different machines and appliances and systems are not coordinated up until the log level. We have different alerts, but the amount of alerts is just overwhelming. There's no organization that can parse the meaningful information out of those log alerts. Let's take the Target example, for example. They had the latest and greatest sandboxing technology in place, that is state-of-the-art that everyone talks about. They had the third-party resources looking at the alerts 24/7, and the boxes did alert. The boxes did alert, but they saw alerts so much that they just decided not to react to it, and 70 million customer records were lost. It is really resource-intensive, and not even the outsourced experts could do it, although they do it all the time, because the overwhelming information and the lack of coordination between the systems. Okay, the detect cycles are quite inefficient, in average 225 days if you look at the data breach investigation report, but it really does vary a lot. If we take a look at the RSA breach a couple of years ago, the detection cycle was 9 days, so pretty good, right? But it doesn't help you a lot if you detect and then remediate. In RSA's case, the remediation cost was $120 million in 1 quarter, because they needed to change all the tokens. The remediation is not enough. Discovering the attacks normally happens by a third party, but although you discover, you need to be able to prevent it, not discover it. So if we look at the requirements of an enterprise security platform that will prevent the targeted attacks, you need to have an integrated security platform that can detect and prevent attacks at each stage of the kill chain, at every point within your network. It needs to cover the virtualized data center part. If you decide to produce services on the cloud, Amazon cloud, you need to have the security capability there. Complete visibility into all traffic, regardless of port, protocol, or encryption. You need to look at the encrypted tunnel. You need to have visibility for all the traffic all the time. Otherwise, you're going to have that G bridge in your network, synchronizing the folders outside of your network. Automated reduction of the attack surface to allow security teams to focus on advanced persistent threats. Let's look at this. Why is next generation firewall there? We need to be able to run our business, safely enable the applications supporting the business. That's the first thing. Safely enable the applications. create closed-loop protections for all newly discovered threats for all customers globally. What this means is that from that unknown that we are now focusing on, when we make that unknown known for known threats, we need to share our intelligence globally in an automatic way in order to make a global learning machine that we know the attacker's tools and the infrastructure as quickly as possible on a global level. And that's exactly what we are doing. We need to cover the endpoint part because, let's face it, most of the attacks include exploitation on the endpoint level, not necessarily going through the network. And mobile devices, as we already talked about. It's not just one box. Integrated platform has to cover whole environment of ours now and in the future as well. I talked to a large company yesterday that had tens of thousands of people working there, and they want to move from 80 to 20 ratio of on-premise application to cloud applications to 50-50 ratio. Cloud is going to be here in no time, in a bang. That's why we need to have a true enterprise platform, security platform that is integrated, that has the next generation firewall capability in those environments where the service production is happening. That is the cloud. That is the virtualized data center. That is the traditional data center. Also the internet perimeter. That is the software-defined networking part. Palo Alto Networks does all of that in an integrated fashion. It needs to cover the endpoint. If it's a Stuxnet, I'm sorry, it didn't traverse the network, was undetected. We need to prevent on the network level and on the endpoint level. I'll show you the details how it's done. And once we uncover unknown threats from the endpoint and the network, we need to share it through an intelligence cloud. That's what we're doing. Let's take a look at the next generation firewall. What we do is inspect all the traffic, block known threats, and send unknown threats to the cloud in order to make them known and shared between the customers. And it's extensible to mobile and virtual networks and the cloud, as I mentioned. And the whole idea is to get full visibility into the network traffic and safely enable the applications that are supporting the business. And then decide on the other applications based on risk, whether we want to have them or not. And if we want to have them, under what conditions should they exist in my network, in my software-defined data center, in my cloud, etc. In order to reduce the attack surface of the attacker. Then we eliminate all known threats from that traffic, allowed traffic, so we can focus on eliminating the unknown threats. Spend the resources on the unknown stuff. I'll come back to analyzing the unknown in a little bit later stage. Let's pretend that now we don't have the network capability at all. Let's look at the endpoint. In the endpoint part, there's been a common understanding in the industry. Even the antivirus vendors have said that they are failing in general in protecting against malware. Symantec said it, other people have said it. There's something fundamentally wrong in the endpoint. But to make things short, we can fix that. What Palo Alto Networks did, we took a white paper approach of endpoint protection, looking at what are the common things in the malware actually exploitation in the endpoint. Seems to be that vulnerabilities come and go. There's a growing amount of vulnerabilities, and detecting those vulnerabilities beforehand, it's not a doable task. Exploits grow in an exponential fashion as well. But there's one thing that is a very steady, and that's the tool sets for the exploitations. So what we call core exploit techniques. There's 23 core exploit techniques that cover the exploits by 99.999%. And those core exploitation techniques need to be chained in an exploitation, which means that you can't use just one exploitation technique in order to deliver your malware into the machine and run it. On the endpoint protection, we have a technical presentation later today, so I will just summarize our solution into one slide. What we do is prevent the exploit from happening. So the attacker never gets the malware run in the machine without the user knowing. So we prevent the exploitation core techniques. The malware is never delivered to the endpoint, so the attacker never gets access. We stop, if it's a Word document, for example, where the exploitation is delivered. We close down the Word document. We notify the user. Now there was this kind of exploitation tried. We'll close the Word document. Please contact help desk. And the attacker never knew we stopped it. We could stop the exploits of, for example, Windows 0-day that are using Windows 0-day vulnerabilities since 2012, every single one of them, by this method. At that point of time, the attack didn't go through. So if you think about our Wildfire, the threat intelligence cloud, we take the memory dump of the endpoint, we collect the forensics, send the file to our threat cloud so that we can analyze it further. What would have happened if that exploitation went through and the malware was delivered into that machine? What is the command and control infrastructure? Is it new? Do we know it? What is the mothership where it's trying to send information? What kind of information it's trying to send? Etc. We could actually take the file, put it to a different environment, and see how the attacker behaves after that. Or our customers could do it, our endpoint customers. It's scalable and lightweight. It doesn't kill the machine itself. You can still do your business with that machine. Our consumption of memory is 0.1%, very lightweight, compared to the normal antivirus agents. So it's a completely different decade, let's put it that way. Integrated with network and cloud security. What we learn in the endpoint, we distribute to all our customers through the threat intelligence cloud and command also the gateway infrastructure that can live in all of those different environments. It can be an appliance form factor in front of your data center, perimeter, virtualized model in the software-defined data center, virtualized data center, etc. All of that infrastructure will immediately get the latest threat information also from the endpoint part. Let's take a look at the threat intelligence cloud that we have today. It gathers information from the customers. Some of you may have heard about Wildfire Advanced Malware Protection. Now the malware that was delivered to the endpoint in my previous example can be sent to Wildfire for analysis, like I said. What would have it done, how it would have behaved, what command and control it would have used. All of that information we analyze and then learn from it and distribute to our clients all over the world. Wildfire has 20,000 devices currently that are sending information to Wildfire. We do 200 signatures every 15 minutes, which means 20,000 malware in a day, malware signatures in a day. That's a gigantic amount. Nobody else does that amount of signatures for new malware, uncovering new malware in the same pace as we do. We found the most Microsoft vulnerabilities months in a row as a company. That's actually how we get into Microsoft, this ring of zero-day vulnerabilities when you get the information of the new vulnerabilities. We needed to produce that information for Microsoft in a gigantic manner years ago in order to get to their programs. Same happened with Adobe. Wildfire is a big contributor for that. Wildfire, what we see in Wildfire is not covered by any of the IV vendors or gateway vendors in the industry. 54% of the malware we see in the first day is not found by anyone else. It doesn't get any better in a week's time. And for example, malware we see in FTP, 95% of that malware is never covered by any of the AV vendors. So it's dependent also for the traffic type. Very powerful service. And the amount of data we get is exponentially growing. Now that we get the endpoint protection feeding into Wildfire as well, you can see where we're going on this. We are taking a big data approach for threat intelligence. And the things we see in the threat intelligence cloud, it's not just the malware signature. It feeds our URL categories if it went through if the malware came through network or internet. Of course, we update our spyware, antivirus detection engines, signatures, the IP addresses, traffic types, what was the application traffic related to, etc. Making unknown threats known can feed all of our detection mechanisms, command and control channel, and help us prevent the attack in all the points of the kill chain, all the time, as efficiently as possible. Not just on the gateway, because world is changing, the networks are going into the software-defined data center. We need to have consistent security capability across all the infrastructure and the endpoints, whether or not the endpoints are the mobile devices or the laptops. By doing that, we can start talking about true integrated approach where you can prevent the attacks from happening. At this point, I thank you for your time. And if you want to hear more about the endpoint protections, Markus Laaksonen, our SC, is going to present the endpoint solution separately and show you a demo on how the prevention mechanism actually works, what it looks like when the exploit happens, what the user sees, what the attacker sees, all that kind of stuff. So I strongly recommend that you participate on Markus's presentation. Any questions from the audience?
Could you reflect that NSS Labs value and map of energy firewall?
The question was on the NSS Labs recent next generation firewall test. So like you might have seen from our blogs, we didn't participate the NSS Labs as a vendor, and our security effectiveness rate was, I think, 60% on that. And there was 12 different evasion techniques that, according to their claim, we weren't able to stop 2 of them. And that's why we got the 60%. Now, when we repeated the tests with our recommended settings, we actually did stop both of them. And now we are asking for one of them more information from NSS Labs. How did they do the test? Because they didn't catch it. And with our default settings, we actually do catch it. So it's kind of a technical yes-no discussion at the moment. That's what happens. So you could say that when we talk about integrated approach, and actually our product is very easy to install and use, without the vendor being able to, or without the vendor being in the test, we got the 60%. Any other questions? Apparently not.
Okay, thank you.
Thank you.